A very good morning to all of you. It's Chandrakala, and once again we are going to continue our physics class. We were discussing second chapter of class 10th, that is work, energy and power. We have seen some common concepts related with work done. We have seen definition of work done, its formula and factors affecting the amount of work done, and we have seen that the amount of work done depends on three factors. First one force, second one displacement, and third one cos theta, that means angle at which displacement is taking place with respect to the horizontal surface. And I hope I have given one example and you have found its correct answer. Yes, I know that. Okay, then we will start from here. See, for this derivation, there are two methods. First one is finding the component of displacement. Finding the component of displacement along force. And second one, finding the component of force. Finding the component of force along displacement. Okay, you can apply any one method and you will get the formula, that is W is equal to Fs cos theta. If it is not spatially specified in the question, you can use any one, but if it is spatially specified in the question, we have to use same method only out of these two. Okay, so before starting the derivation, you see there is one word, that is the component. In both the methods, you will have to find out the component. In first method, you will find out the component of displacement, and in second method, you will find the component of force. But in both the methods, you will have to find out the component. So first of all, what is this component? You see, we know about vector quantities. It will have direction as well as magnitude. So, if there is a body and you are applying force on it, and because of that force, if it is moving in a straight line, that means if the motion is a straight line motion or rectilinear motion, then we do not need components. That means we will not need any specific direction, right? But in the last class, we have seen that it is always not necessary that the applied force will move the object in a straight line only. That means it can also move this object in any other direction than a straight line, at any angle. This we have seen. And it depends on the point of application of force. That means at which point you are applying force. Accordingly, there will be displacement. Okay, that means, and this is because of the direction, and direction is associated with vector quantities. That means for any vector quantity, there are two components. Okay, so if it is moving in a straight line, it's not an issue. But if it is moving another direction than this straight line, suppose in this direction displacement is there. In that condition, this displacement is having two components. One is the horizontal component and another one is the vertical component. That we know that this is x-axis and this is the horizontal component, this is y-axis and this is the vertical component. Okay, so that means this is our displacement and we will apply one force here, and we have to find out either the component of displacement or the component of force. Okay, so this is the component. That means if the object is moving in any other direction than the straight line, then we will need component of that vector quantity. Okay, that is the component. So now we will start our derivation. That is first one. We are going to derive work formula with the help of first method. That is, we will find the component of displacement. Component of displacement along force. Displacement along force. Okay, done. Suppose there is one object. This is one object. Okay, you have applied force on this object. This is force F. You have applied F force on the object, and simply, if the object is moving in the straight line, there is no matter. But instead of straight line, the object is moving at some angle, that is at an inclined plane. It is moving here. Initially it was here. After some time the object was here, and now the object is here. Object is moving like this. That means this object is at an angle theta with respect to horizontal. Okay, so you have applied force F on the object. Because of this force, the object is moving in this direction, and this direction or this line makes an angle theta with the horizontal surface. Okay, so now you see, we have to find out the component of displacement. So if the object is moving from here to here, this is displacement only. Okay, so this is displacement, and let it be S. We know that any vector quantity is denoted by this arrow sign. That means this represents the direction of the vector quantity. So this is the displacement and this is the force. Okay, now see, first of all, what we have to do, we have to make this horizontal line. That is our straight line, and then we have to draw one perpendicular on this horizontal line. Perpendicular means 90 degree. Okay, initially suppose the object or body was at a point A and now it is at point B, and we have drawn one perpendicular from B and we will name it as C. Okay, here we have discussed that any vector quantity has two components, one horizontal component and one vertical component. It's okay. Here also we will have two components of this displacement, one horizontal component and one vertical component here. But we do not have to do anything with this vertical component. So we have not drawn this vertical component. Why? You see here, along force. That means we want a component which is along in the same line with the force. That's why we want this component only, horizontal component. If you are applying force from this direction, then you will need the vertical component. But right now we need only one component, and that is the horizontal component, because it is along the force. That means in the same direction in which the force is applied. So now we have got a right angle triangle ABC. Let's once again we will see this. See, our first method is we will find the component of displacement. We know component. Any vector quantity has two components, one vertical component and one horizontal component. So there was one object and we applied some force on the object. Because of this force, the object starts moving along one inclined path, and this is the displacement. After some time the object reach here, and this displacement is S. That means this object has covered S distance from here to here. Now we will have two components of this displacement. One is the horizontal component and one is the vertical component. But we are not taking this vertical component because in our heading we want component of displacement along force, and force is in this direction. So we need only this component. We do not need vertical component here. Okay, now we have a right angle triangle here ABC, and now we will derive our formula. Now this is our final diagram for the derivation. We have applied one force F on the object, and this is the displacement covered by the object. Then we drawn one perpendicular on the horizontal straight line and we named it as ABC. Now see, we know that what we have to derive. Finally, we have to derive W, amount of work done, is equal to Fs cos theta. See, F, amount of force, we have already decided that the amount of force applied is F only. That means F we have. We have to find out the component of this displacement. This we have to find out. That means this we have to derive finally. And what we want right now is W is equal to F we have, the amount of force applied on the object is F, into we want component of displacement. Component of displacement. This we have to find out. Okay. So for finding the component of displacement, we will need, see, this is perpendicular. This is perpendicular. That means this is perpendicular and this is base and this is hypotenuse. This is a right angle triangle. We have drawn one perpendicular. So this side is known as perpendicular. This is base and this is hypotenuse. Okay. Now from here, from this right angle triangle, we will calculate value of cos theta. You see, we have discussed that this displacement will have two components. One horizontal component, one vertical component, and what we want horizontal component of this displacement, and this is the horizontal component of displacement, that is AC. So what we want is F we already have, and the component of displacement, which component? Horizontal component of displacement is AC here. So we will write AC. This we have to calculate. We want this AC. For this AC, from this right angle triangle, we will calculate the value of cos theta. You see, cos theta. We know that cos theta is equal to base upon hypotenuse. This we know. Now the first question is, why only cos theta? The reason is, you see, this is the right angle triangle, and here this is perpendicular, this is base, and this is hypotenuse. Now you want this side according to your formula. You want this side. So you have to include base. And if this is unknown, we don't know what is the value of AC. So if it is unknown, then you need at least one known quantity. And that known quantity is this hypotenuse. This is S. This we know. So one unknown quantity and one known quantity. That means one base and this hypotenuse. That's why we have taken cos theta, because cos theta includes both base and hypotenuse. That's why we have taken cos theta, because we want only the horizontal component. If we will need this vertical component, then it will be sin theta, but this right now we do not need it. We need only this horizontal component. That's why from this right angle triangle, we are calculating only cos theta. Okay, so if I will write cos theta is equal to base. Base means AC. Am I right? Base is AC. So instead of this B, I can write AC. And hypotenuse. Hypotenuse is this one, AB, right? So instead of this hypotenuse, I will write AB. Okay. Now you see, cos theta is equal to AC. We don't know what is the value of AC. So we will write as it is AC. Okay. But we know the value of AB. How much it is? S. We know that the displacement is S. So we will write here S. Now from here, can you calculate value of AC? AC is equal to S into cos theta. Now we got value of AC for our formula. See here. W is equal to F into AC, and AC is equal to S cos theta. So we will write S cos theta, and W is equal to Fs cos theta. Is it our required derived formula? Yes, of course. That means in the first method, we have calculated the component of displacement along force. This is the first method. Now we will discuss second method. Second method means we have to find out component of force. Finding component of force along displacement. Okay, nothing special we are going to do. We are going to use same things which we have used right now. Same things means the same formula. Same formula. Okay. So this is our second method, finding the component of force along displacement. Same diagram we will draw. We have taken one object and we have applied a force. Because of that force, the object is moving in this direction, and you see this is force. Okay, and this is displacement again, that is S. This is displacement. All right, this is force. Okay, and this was our previous diagram which we used in first method. In first method we used this only, that we drawn one perpendicular on the horizontal surface and then we calculated value. This time what you have to do, you want component of force, means this force this time we will need. Okay, component of force along displacement. That means along displacement. If displacement is in this direction, then you will need component in this direction. Force is applied in this direction. You are applying force here. This is F. You are applying force here and you need the component of force. This is force. Force will also have two components. One vertical component, one horizontal component, right? But this we do not need again because we want component along the displacement. So this is the component of force at angle theta. Okay, same thing we will do. We will draw a perpendicular here and this is the perpendicular. This is the perpendicular you have drawn here. So now this triangle, you see in this triangle this is 90 degree. So this is perpendicular and this is again base and this is hypotenuse. Now we are talking about this right angle triangle. You can name it anything. If you want ABC, if you want anything else, then you can name it. Suppose this is N. This was already, we named it as A and let it be M. Okay, so now we have what? Triangle NAM. NAM. Okay, once again you see there was one force applied on the object. Because of the force, the object displaced in this direction. And now we want the component of force. So force is applied at this point. At this point the force will have two components, one vertical component and one horizontal component. Again we need only horizontal component, that is this line. Then same way we have drawn one perpendicular on this horizontal component. Here also we had done same thing. This was the horizontal component and we drawn perpendicular. Similarly, this is the horizontal component and we have drawn perpendicular here. Okay, so finally this is our diagram. If I will make it more clear, then it is like this. This, where this is 90 degree, this is perpendicular, this is base and this is hypotenuse. This is named as A, this is N and this is M. So we have now this right angle triangle, that is A and M, right? This right angle triangle. You can write it as A and M because this is a right angle triangle. No problem. Now you see, from here also we will calculate value of cos theta. But before that, we know that what we have to derive. We have to derive work done, that is equal to force into displacement into cos theta. This time the displacement is given as already. We have to find out the component of force and this is the component of force, that is NA. So what we want is amount of work done is equal to component of force. We want component of force into displacement. This is already last time F we were having and we found component of displacement. This time S we are having and we will find component of force. Okay, so you see for component of force, see here This is the component of force. This is force and this is at angle theta. So this is component. So what we want is basically NA. So here we can write amount of work done is equal to NA into S. Okay. Now we have to find NA. Again we will go to cos theta is equal to base upon hypotenuse. Why again cos theta? Because we need one this side NA and one known side, that is this one, hypotenuse. So again we need base and hypotenuse. That's why we are using only cos theta. So cos theta is equal to base means this one, that is NA, and what is another one, that is hypotenuse, and hypotenuse is F. We know that the amount of force applied is F. So we will write here F. Okay. From here, can you calculate the value of NA? Of course you can calculate. NA is equal to, take it here, that is F into cos theta. So have you got the value of NA? Then instead of NA, can you write here F cos theta into S? So is it your familiar formula? Fs cos theta. That means we have derived this same formula by two methods, that is Fs cos theta. Like this, we can derive this formula by any one method. If it is not specified in the question, you can use any one. But if it is especially mentioned in the question, then you have to use accordingly. Right? Now you have got the formula and you will get some numericals and examples in the exercise that you will try along with it. Okay, rest of the things we will see in the next class.